This is lesson 28 in your textbook, and it's weird. Like it's a strange thing. Now listen, I have to first show you the formulas that we are using to solve these. So the first two things we're going to look at are ridiculously confusing, I feel like. So I'm going to show you those because those are the formulas. And then once I start like using them in the problems, hopefully it will make more sense. I'm also going to do mine slightly different than your textbook does because I feel like the end part of this, your textbook makes a little bit harder. So just know this is a little bit weird. Don't get bogged down and quit. Keep watching because we're going to do several of them. Work them with me, and we'll see if we can get through this. All right, do not freak out because this looks terrifying. Just the actual work makes way more sense than this, but I'm going to show you the formula. And the formula is like an equation or a set of information that is true and that I can plug values in to solve. And the way that we work, these are more working with roots and squaring, but it's in a different format. So here's the first thing I want to show you. Now listen, this is even tricky for me. This makes way more sense to just do these problems than to think about this, but I need you to understand something, okay? The way these are written, if I have, you're going to be given something like this. Let me not use a 1. Let me use a 2. 2 to the 2/3. This is your base. This is your power. This is your root. And that translates into a radical as the base, power, root. So in this case, my base is 2, my root is 3, and my power is 2. Now, this is weird, so just give me a few minutes. Do not quit from here. Let's just keep going. Now let me clean this up a little bit because I think I actually just have this typed out again in another form. So B is for your base, P is for power, R is for root, and I'll just write that down real quick. And you may want to try to take some notes if you're a note taker. B is your base, P is your power, or we probably would be more familiar with exponent, and then R is your root. Okay, so when we have something like this, 8, oh sorry, I wrote over it. 8 is my base, 2 is my power or my exponent, 3 is my root. Now let's talk about how to solve these, okay? It's going to really just sort of make more sense as we jump into actually doing these over and over. Hopefully you'll see what we're doing. So the problems are going to look like this. They're going to be a base number with a fraction for an exponent. Okay, so the reality is that small, it's kind of hard to see what it's saying. But if I write this out, it's going to look like this. 4 to the 1/2 power. And this is going to be where we sort of put certain things. So remember, we have the base. Let's call our numerator the exponent. And then the bottom number, the root. Okay? So in order to solve these, we're going to have a radical sign. Our base goes inside. Our exponent goes where an exponent normally goes, and our root goes in what's called the index. So it's base, exponent, root. All right, that's written terribly messy. And now the way we solve this is, so order of operations, we're going to solve inside first. 4 to the first power is simply 4. Now we're going to take our square root. The square root of 4 is simply 2. So translating from here to here is where this is going to be weird. So let's do a couple, well, probably several more. We have to just remember where our base is, where our exponent is, and where our root is. Let's do some more. So this is 27 to the 1/2 power. So let's remind ourselves over here, and you may want to write this down somewhere. You have your base, your exponent, your root. So let's draw our radical sign. Your base always goes inside. Your exponent, you know where the exponents go, and then your root goes out here. Base, exponent, root. Now in this case, 27 to the first power is 27. There is not a simple square root. So when we get to the place that there's not a simple square root, we have to reach back into our how do we simplify it. We have to tree it. We have to pair it. So I'm going to tree my 27 into 3 times 9, 3 times 3. The square root of 3 times 3 times 3. So remember in our lesson, when we have a pair of numbers under our radical, it pulls out as 1. When I have a pair of numbers under the radical, it pulls out as 1, and my leftovers stay. So what I have is 3 times the square root of 3, and I don't really need to put that 2 there in the index because the square root's understood. All right, so I'm telling you, this is strange. It's another way to work with radicals, and then we're going to have to slow down and remember how to reduce these things. So let's do another one. All right, so let's look at this one. We have 27 to the 2/3 power. Remember, the big number is my base, the top is my exponent, and the bottom is my root. So base, exponent, root. Order of operations says I start inside my radical symbol there. So what I end up with is the cubed root of 729. Now, if it will simplify down, then I get my answer. If it won't, then I have to do that whole tree it and all those kinds of things. Listen to me. Before you jump into treeing it and simplifying it, type it in your calculator and see if it simplifies. So I have to do on mine, I have to kind of press several buttons in an order. And if you don't know how to type this in your calculator, you need to let me know so I can sort of send you a video. I'm going to type in the cubed root of 729 in my calculator to see if I get a whole number. If I get a whole number, that's my answer, and I don't have to do the whole thing. And in this case, I get 9, which means my whole answer is simply 9. Now, here's the thing. If I type this as a math problem using the house top for my fraction, so if I do 27 house top 2/3 and I hit equals on mine, I'm going to get this answer. The problem will be when I don't have a solid answer. So like if I were to give you 27 to the 1/4 power, I type that in my calculator and I get a decimal form. That is not the correct answer. Your answer must be in a root form, okay? Always try it first. If you get a whole number, that is your answer. If you don't, you'll have to simplify it. So let's do one like that. All right, this one is not going to simplify quite as easily, so let's work through this one. So remember, we're going to do our radical sign. Our base, the should not be talking while I'm writing. The denominator is my exponent. The numerator is my root. Base, exponent, root. Solve inside my radical first. 16 squared is 256. Now, always try it first. Type it in your calculator, cubed root of 256. When I hit equals, I get a decimal. That means there's not a whole number radical, which means I have to do all of that, breaking it down, finding any pairs to pull out, okay? So I'm going to break down 256 because it's 16 squared. I know that it's 16 times 16, and so 2 times 8, 8 is 2 times 4, and I'm going to run out of room. 2 and 2, 2 and 8, 2 and 4, 2 and 2. Hopefully you can even read that. Let me just rewrite this. So basically I have 1, 2, 3, 4, 5, 6, 7, 8 2s at all of my endpoints. Now, because it is a cubed root. I have to have sets of 3 to pull out. Here is one set of 3. Here is a second set of 3. And here are my leftovers that have to stay inside, okay? Every pair pulls out as 1. So there's my first set of 3. There's my second set of 3. And then what is left has to stay inside. Remember, if it's a square outside, I need to find pairs of 2. If it's a cubed outside, I have to find 3. If it's a 4 outside, I'd have to find 4. And then I multiply. 2 times 2 is 4. The cubed root of 2 times 2 is 4. This is my answer, and here's why people hate algebra, because that's not any easier than what I started with, but that's going to be the simplified answer. All right, let's look at one more, maybe 2 more, we'll see. What I would really, really like for you to do is I would like for you to try this one on your own. Remember, base, exponent, root. Your big number is your base, your top is your exponent, your bottom is your root. Work this one on your own. If you have absolutely no idea, just go back and rewatch what I've already done. And then push play again. So try this one all by yourself and then come back and work it with me. We'll check your answers. Okay, hopefully you've all tried this on your own. Remember, we have our base is our big number. Our exponent is the top, and our root is the bottom. Base, big number, exponent, top, root, bottom. I'm going to start by solving inside of my radical, and this one's easy because it's just 32 to the first power, which is just 32. Now, always, always, always type it in your calculator, cubed root of 32, and I get 3.174, yada, 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 which means I have to simplify this by treeing it, okay? Now I'm going to do this one as I go. So 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, which is 2 and 2. Now, because I have a cubed root, I have to have 3 to pull out as 1. Every set of 3 is going to pull out as 1, which is going to give me 2, and I have 2 left over in here, which 2 times 2 is 4. And the reason this isn't simplifying, because it's the cubed root of 2, not the square root of 2. And that is my answer. So let's try one more. All right, I would like for you to try this one also, and then come back and work it with me. So hopefully now that you've tried it, we're going to work it. Remember, draw your radical sign, your base, your exponent, and your root. So we're going to solve under our radical first, which is 100 squared, which is, oh, my pencil, there it goes, which is 100 squared, 100 times 100 is 10,000. Now I need the fourth root. Before I begin to break it all down, see if there is a 1, 2, 3, fourth root. And in this case there is, so the answer is just 10. All right, base is your big number, exponent is your top, root is your bottom number. All right, just do your best. If you get totally stuck, rewatch the video and go from there. For homework, you're going to do activity 2 on lesson 28, just activity 2. I'm not going to make you do a whole bunch of other review work because this is all this new concept, all right? Do your best. If you get stuck, send me a text message. So it's activity 2, lesson 28. Remember, we're doing everything in your book this week, and I'll take it up later and grade it that way.